Hey guys, welcome. Hope you have had an awesome day so far. Today we're going to go ahead and go into our second lesson on standard and vertex form of quadratics. First, we'll go ahead and recall real quick what we talked about in our previous lesson about standard form and vertex form of quadratics. Please remember standard form is in the form ax squared plus bx plus c, and we find our vertex by setting x equal to negative b over 2a. We then plug it in to find the y, and make an ordered pair out of the two values to have your vertex. Vertex form is a little bit more simple. It's already in a very specific form for you. The number that's being added or subtracted from the x is the x value of your coordinate, and the number added onto the end is the y value of your coordinate. I'll go ahead and start you off with these following examples, and then I'll let you go and fill in the rest on your own. To find your vertex in this first example, I let x equal negative b over 2a. So I have negative b, but b is a negative 16, so I have two negatives, all over 2 times a, and a is a negative 2. This becomes positive 16 over negative 4, which is a negative 4. That's the x value of your vertex. We now plug it in to find the y. I've got negative 2 times negative 4 all squared, minus 16 times negative 4, minus 36. This becomes negative 2 times positive 16, minus 16 times negative 4, minus 36. Negative 2 times 16 is negative 32, plus 64, minus 36. Negative 32 plus 64 is a positive 32, minus 36, which is a negative 4. So what we just found is our x value of our vertex is negative 4, and so is the y value. Now to identify the direction, all we're going to do is look at that leading coefficient of negative 2. Since it's negative, that implies that our parabola is facing downward. If it were positive, it would be an upward-facing parabola. To the left, this is already in vertex form. Your x value is the opposite of whatever is being added to x. If there's nothing inside the parentheses with x, then your x value is just 0. But here, since I have a plus 1, my vertex has an x value of negative 1, and this y value is the value added onto the end, so a positive 1. Looking at the leading coefficient, or the very first value in your equation, there is a 1 in front of the x. It is a positive 1, so the direction of this parabola is up. Go ahead and pause the video and try those next few on your own. Okay, go ahead and pause the video again to check your answers, and I'm going to go ahead and move on to our next slide. Here on our next slide, we're going to follow these 3 steps to graph each of the following quadratics. Step 1, you got to find your vertex. So looking at this first example, I'm going to find my vertex by letting x equal negative b over 2 times a. Since it's in standard form, I must use this method to find the vertex. My b is negative 8, so I have negative 8 over 2 times my a, but looking at this coefficient in front of x squared, it's just a 1, so I have 2 times 1. That gives me positive 8 over 2, which reduces to positive 4. To find my y value, I plug in this positive 4 to get 4 squared minus 8 times 4 plus 20. 4 squared is 16 minus 8 times 4 plus 20. 16 minus 32 plus 20 is negative 16 plus 20, which is positive 4. So your vertex is a positive 4 for x and a positive 4 for y. I'm going to go ahead and put that on my graph. We found our vertex for the first example. Now step 2. We're going to determine the appropriate pattern. In our previous video, I introduced you to the pattern that we use when our coefficient is just 1 in front of the x squared. If the coefficient is just 1, your pattern is as follows. From your vertex, we go left 1 unit and up 1. So left 1, up 1, here's my point, and then I go left 2, up 4. From the vertex, I then go right 1, up 1, and right 2 from the vertex, up 4. Your y value should always be on the same value because our graph is symmetrical. So if you ever have different y values, then you should know that you made a mistake. Since my graph is symmetrical, I assume I did it correctly, and your parabola should look like this. Note, if the leading coefficient is not 1, then your pattern changes, and we'll address that later in the video. Step 3, after we determine the pattern, we plot the points and graph, which we did. So we'll go ahead and follow these 3 steps for the example on the right. Find your vertex. Here it's much more simple than in the example on the left. I take the opposite of the number being added to x, that's a positive 3, and then the number added on the end is my y value. I plot this point, 3, 2, and then look at the leading coefficient of your equation to figure out if your pattern is going to be the standard pattern above. The number in front of your x squared is a 1, so we will follow the pattern that I have above here. Your pattern tells you from your vertex we're going to go left 1, up 1. So I go left 1 and up 1 to the point 2, 3. And then from the vertex I go left 2, up 4 to the point 1, 6. Going back to my vertex I go right 1, up 1 to the point 4, 3. And right 2 from the vertex up 4 to the point 5, 6. Connecting my dots, I then graph my parabola in one smooth curve, and your graph should look like this. Here I'd like you to try this slide on your own. First thing you need to do is check, is the leading coefficient 1? This should be your very first step. Then, if it is, which in these cases your leading coefficient is 1 because in front of the x squared there are invisible 1s. Since this is the case, you're going to follow the normal pattern which I displayed to you on the previous slide. So go ahead and pause the video and try these 2 on your own. Go ahead and check your work and notice that your graphs should actually be exactly the same. They're just in different forms. One has the equation in standard form while the other has its equation in vertex form. Now we're going to go ahead and again graph these 2 quadratics. However, I'd like for you to note that the leading coefficient in both of these is not 1. Here I have a leading coefficient of 2, and on the right again a leading coefficient of 2. So the change is that we are going to multiply the ups in our pattern by this leading coefficient. So step 1, I find my vertex. My vertex in standard form, I find my x by formula negative b over 2 times a. So I have a negative b, and b is a negative 8, over 2 times a, which is a positive 2. 8 over 4 reduces down to a positive 2. Plugging that in, I will find my y value of my vertex. F of 2 is 2 times 2 squared, minus 8 times 2, plus 6. This becomes 2 times 4, minus 8 times 2, plus 6, which is 8 minus 16 plus 6, which ends up being a negative 2. So your vertex is the ordered pair 2, negative 2. I'm going to go ahead and put that on my graph. Now to follow my pattern, normally I go left 1, up 1. And I go left 2, up 4. But my leading coefficient is not 1 anymore, now it's 2. So what I'm going to do is multiply the entire up section by that leading coefficient of 2. So instead of left 1, up 1, I'm going to go left 1, up 2. And instead of left 2, up 4, I'm going to double the 4 and go left 2, up 8. So I multiplied those up values by my leading coefficient. And then same thing with the rights. Right 1, up 1 is my normal pattern, and right 2, up 4. However, my leading coefficient is 2, so I'm going to multiply these ups by that leading coefficient. So instead of right 1, up 1, multiplying that by 2, I'm going right 1, up 2. And instead of right 2, up 4, I'm going up 8. So from my vertex, I'm going left 1, up 2, and left 2, up 8. So 1, 2 to the left, 1, 2, 3, 4, 5, 6, 7, 8. On the right, starting from the vertex, I go right 1, up 2. Going back to the vertex, I go right 2, up 8. And remember, that's going to be on the same level as the point you plotted on the left. Connecting the dots in a nice smooth curve, we graph our parabola. Because we doubled all of our ups, your parabola will become much more narrow than it was before. On the right, first thing I'm going to do is find my vertex. It is opposite of the number being added to the x, so here it's a -3 for my x value and a -4 for that y value. So I go left 3 down 4. This is my vertex. Now I'm multiplying all of my ups in my pattern by a +2. So my pattern normally goes left 1, up 1, left 2, up 4, right 1, up 1, and right 2, up 4. However, I'm going to multiply all of those ups in my right-hand column by that leading coefficient of 2. So instead of up 1, I'm going up 2. Instead of up 4, I'm going up 8. Instead of up 1, I go up 2. And instead of up 4, I go up 8. Now from my vertex, I follow my pattern and graph. Left 1 up 2, left 2 up 8, right 1 up 2, right 2 up 8. And we connect the dots in a nice smooth curve. The last thing I'd like to expose you to is what if your leading coefficient is not only something different than 1, but what if it's also negative? So notice, in both of these equations, my leading coefficient is negative. Well, what we've talked about before is that takes your parabola and makes it face downward instead of upward. So the only change here is that all of your ups are going to become downs. Other than that, everything remains the same. Step 1, I find my vertex. In this example on the left, my vertex follows the formula where x equals -b over 2 times a. So x equals -12 over 2 times -2, which is +12 over -4, which reduces down to a -3. So the x value of my vertex is a -3. Plugging that in, you guys can do that on your own, you should get a -4. So your vertex is at the point -3, -4. From here, we follow our pattern. Normally your pattern says go left 1, up 1, left 2, up 4, and right 1, up 1, and right 2, up 4. However, we have a leading coefficient that is not 1. It's now a -2. So the negative is going to change all of my ups to downs, and the 2 multiplies my number by 2 to give me a down 2. Instead of up 4, I'm going down, and I multiply 4 by 2 to get 8. Instead of going up 1, the negative makes my graph go down, and I multiply 1 by 2 to get 2. Instead of up 4, I'm going down, and 4 times 2 is 8. So from my vertex, I go left 1 down 2, left 2 down 8, right 1 down 2, and right 2 down 8. So now your graph is a downward facing parabola. To the right, finding your vertex should be a little bit more simple. Your vertex has an x value that is opposite of the -4 that's added to the x, and the y value remains the same. So I have a vertex of 4, -1. From here, my pattern is going to be multiplied by a -3. So instead of left 1, up 1, I'm going left 1 and down 3. Instead of left 2, up 4, I'm going left 2 and down 12. Instead of right 1, up 1, I'm going right 1 and down 3. Instead of right 2, up 4, the up becomes down, and 4 times 3 is 12. So following this pattern from my vertex, I go left 1 down 3, left 2 down 12, right 1 down 3, and right 2 down 12, and connect the dots to create my parabola. Go ahead and try this next and last slide on your own, and have an awesome rest of the day.